Integrated Math 7-8 students. We are working in Module 13, and this is Lesson 2, and it's called Multiplication and Division of Numbers in Exponential Form. Multiplication and division of numbers in exponential form. Okay, and here is our notes page. All right, so our goal today. Today we will learn how to multiply numbers in exponential form. The question that I want you to be thinking about is, what rules can you determine for multiplying numbers in exponential form? All right, some things to know. I am going to give you a warning that we have 2 pages of notes today because there's a lot of new information that you haven't learned yet that we need to make sure you have written down. So our things to know section says when you're multiplying numbers with same bases. Okay, so I want you to think about our lesson from yesterday. You now know what it is when I say base. Base is the big number in the power. Exponent is the small number in the power. So we're thinking about the big number in the power when you multiply numbers with the same bases. When multiplying numbers with the same bases, you add the exponents. Interesting. So let's take a look at it. If we have 8 to the second power times 8 to the 7th power, so you will notice their bases are the same. Okay, so that means 8 times 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 8. That's what that means. So instead of having to write all of that out, what we want to prove is we want to know that if your base is the same, can you add 2 and 7 and come up with the correct answer? Okay, and so it says when multiplying numbers with the same bases, you add the exponents. And so what we have to do is we have to check it. We have to prove it to see if this works. So it says, why does this work? Write out the powers in expanded form to see what you have. Okay, so 8 to the power of 2 means 8 times 8. So this right here is 8 to the power of 2. Okay, 8 to the power of 7 is this right here, right? That's what it looks like when it's expanded out. So basically, what you're really doing when you take 8 to the power of 2 times 8 to the power of 7, look at how many 8s you have. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 8 to the power of 9. So it really does work that if your bases are the same, you can take 8 to the power of 2 plus 7, and it gives you 8 to the power of 9. All right, and if we use a calculator, I'll pull out my calculator to prove it. Okay, we have on our calculator, remembering how to use the exponents on there. So you have 8 as your base, little caret button, to the power of 2, okay, times 8 to the power of 7 equals that ginormous number. So I'm going to write it down so we can check it and see. So we have 1, 3, 4, 2, 1, 7, 7, 2, 8. All right, and so very large number. Now I'm going to try something different, so clear it out, and now I'm going to take 8 to the power of 9 and see what it gives me. Ta-da! The exact same number. 1, 3, 4, 2, 1, 7, 7, 2, 8. So it works. Okay, and so what you've just learned is you've learned your first rule that when you're multiplying numbers with the same bases, as long as the base is the same, all you have to do is add the exponents. And that means you don't have to write all of this out and try to figure out what it would be. Okay, so that's a good one to know. Okay, the next thing that you need to know is raising a power to a power. What this means is it means taking the given power and raising it to another power by applying the second exponent. Now, yesterday I heard a comment in class, and I can't remember which class it was. I never knew you could take a power by a power by a power. And the answer is yes, you can. So let's take a look at it. Our base is 2. We're raising it to the third power. So that means that we have 2 times 2 times 2. But then it's asking us to do that 6 times. So what that means is, when you see it written like this, is you're going to take 2 to the third times 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 2 to the third, because 2 to the third is our base, and we're doing that 6 times. But then, in order to figure out what this answer is, you have to expand it out to see what you're actually doing. So what 2 to the third means is 2 times 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 2. Oh, that's a lot of writing. But this is the expanded form of what that is saying. And so what mathematicians think is that there has to be a faster way to do it. Before I show you the faster way to do it, let's count how many 2's you're multiplying. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Do you see something that might help you right there in that example? So we get 2 to 18 times. We counted them. So when you raise a power to a power, you keep the base the same and you multiply the exponents. Aha! Notice the difference? When you're multiplying numbers with the same bases, you add the exponents, but when you're raising a power to another power, you multiply the exponents. Because 2 to the third 6 times is the same thing as 2 to the 18th power. Okay? So, something to remember. Remember that you cannot combine powers that do not have the same basis. So, for example, if we have 2 to the 5th times 3 to the third, you may not combine anything because when we write it out, look at what we have. We have 2 multiplied itself 5 times. We have 3 multiplied itself by 3 times, and you cannot combine them without multiplying. So when you have 2 times 2 times 2 times 2 times 2, that means 2 to the 5th power times 3 times 3 times 3, which means 3 to the 3rd power. So the only way that either of these two rules will work is if the bases are the same. If the bases are different, the answers are exactly what they were when you started. 2 to the 5th times 3 to the 3rd is equal to 2 to the 5th times 3 to the 3rd, and then when you actually do the math and figure it out, then you'll see the answers. But this is the only way that you can write this because the bases are not the same. Okay? All right, so that's multiplying. Multiplying numbers with same bases, you keep the base, add the exponents. Raising a power to the power, you keep the base and you multiply the exponents. Okay? So now we're moving on to dividing because our lesson said multiplication and division. So in dividing numbers with same bases, it actually is very similar to what we did, except up here we were adding. So if you're dividing, what do you think you're going to do? If you said subtracting, you are correct. So it says when dividing numbers with the same bases, key part is same bases, you subtract the exponents. So if we have 9 to the 6th divided by 9 to the 5th, are the bases the same? The answer is yes, they're both 9. So you take your 9 and then you subtract your numerator and your denominator. So it would be 9 raised to the 6 minus 5, which 6 minus 5 is 1. Okay? Now, some of you are thinking, well, how does that work? Okay? And it says, why does this work? And so we're going to show you right here. The reason why it works is write out the power in expanded form to see what you have. So 9 to the 6th looks like 9 times 9 times 9 times 9 times 9 times 9. 9 to the 5th looks like 9 times 9 times 9 times 9 times 9. So now you're just looking at how can I simplify to 1? Well, I know that 9 divided by 9 gives me 1. 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 What's 1 times 1 times 1 times 1 times 1? It's 1 times 9. 9. So what's my answer? 9 to the first power because 9 to the first power is 9. Does everybody see how when you're dividing numbers with same bases, all you have to do is take the base and subtract the exponents? And we just proved why it works. Okay? The thing to remember about dividing is think, what am I doing? I'm dividing. So I divided everything out to 1. Okay? So that's how we were proving that that works. So as long as you have the same bases and you're dividing, then you subtract your exponents. Okay? All right, so moving on to the next part. There is something that I want you to think about, and this is kind of cool, okay? And this will come in handy with our next lesson too, so you really need to pay attention to this pattern. So if you have 2 to the 6th, that means you have 2 times 2 times 2 times 2 times 2 times 2, which equals 64. Well, what happens when you have 2 to the 5th? 2 times 2 times 2 times 2 times 2 is what it equals. So now let's do the math. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So this one is 32. All right, so now let's do the next one. 2 to the fourth. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Good job. Okay, so now let's do the next one. 2 to the third. 2 times 2 is 4. Times 2 is 8. Good. Do the next one. 2 times 2 is 4. That is correct. So we have this. And then the last one, it says 2 to the first power, so you just have 2. 2 times 2 is 2, right? And then what's happening here? Uh-oh. What's happening here? Huh. Interesting. So what is the pattern that you see? How did you get what actually happens when you go from 2 to the 6th to 2 to the 5th? We're at 2 to the 6th here. What actually did we do? If you have 64 and you went to 32, what happened? If you had 32 and you got to 16, what happened? If you were at 16 and you got to 8, what actually happened? If you were at 8 and you got to 4, what actually happened? If you were at 4 and you got to 2, what actually happened? So what would go right here? So if you're thinking that you're dividing by something each time, then you are correct. Okay, so we look at here, 64 divided by the base, which the base is 2. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So what is 2 divided by 2? And the answer is 1. Okay, so as you're going down in exponents, okay, 6, 5, 4, 3, 2, 1, 0, you're just dividing by the base. So the pattern that you see is we're dividing by the base. What actually happens when you go from 6 or 2 to the 6th power to 5 or 2 to the 5th power, you're dividing by 2. Okay, so now I want you to show me this one, and we're going to check this in your notes when I look tomorrow. Show me the process of going from 10 to the 6th to 10 to the 0. So this one was 2 to the 6th down to 2 to the 0. You're going to show me 10 to the 6th down to 10 to the 0 and see if you can figure out the pattern that's happening. Okay? And then the last one that I want you to do, let me spread this out just a little bit. The last one that I want you to do is, now try this one. You're going to take 2 to the 5th divided by 2 to the 4th times 3 to the 7th divided by 3 to the 6th. So you're going to multiply those together, which you can't do because they don't have the same basis, but I want you to do the division part. And then I want you to do it 3 times, okay? Because we're practicing the rules that you just learned. Remember, if you're dividing by the same basis, all you have to do is subtract the exponents. So I would start there. Your base is 2, subtract these exponents. Your base is 3, subtract these exponents, and then do it 3 times and see what happens. It's kind of fun. It's a good challenge problem to see if you understand what we were doing. Those are the 2 I'm checking in your notes. For those of you who haven't been doing them during note time, you have to do them, okay? Make sure this one is done, and make sure this one is done for when I check your notes. And that's all I have for you. Let's go back to our goal really quickly. Today we will learn how to multiply numbers in exponential form. We did that. We also learned how to divide them. What are the rules you can determine for multiplying numbers in exponential form? Multiplying numbers with same bases, what do? Add exponents. Raising a power to the power, as long as the base is the same, you multiply the exponents. Dividing numbers with the same bases, you subtract the exponents, okay? So I want you to practice all of those on those last 2 problems that are right here that you can actually see. So try this one on your own. Show me the process of 10 to the 6th power down to 10 to the 0 power, and then also try this one. 2 to the 5th divided by 2 to the 4th times 3 to the 7th divided by 3 to the 6th, and then do that 3 times. Raise to the power of 3. Okay? That's all I have for you. It's getting exciting. Have fun. See you tomorrow. Bye.